Hello everyone, welcome to this SWAM-NPTEL online course on space environment and its effects on orbital spacecrafts. So, these days we are discussing the neutral environment and our current topic of discussion is the orbital debris. So, in the last session we discussed that is how to deal with the spacecraft debris or that is the orbital debris, and we discussed the that is the international cooperation. So, in terms of the space situational awareness, and in this regard we discussed that is the interagency space debris coordination IADC, and we discussed that is the how the debris are monitored and it is catalogued through the tracking and detection, and the techniques used for the tracking and detections. One is the radar techniques, the other is the optical techniques using the optical telescopes. So, today we will be discussing the next step. Once you monitor that is you detect it or you are able to track it, the next is to the capture and to deorbit the debris. So, we will discuss two methods. One is the contact capturing method, the other is contactless capturing method, and whatever the method I am going to tell so these are not the unique, there can be the other methods also, but these are the materials which I have gathered from the which are the published in some of those the papers which are available. And the removal of, we will also discuss the removal of orbital debris maybe in the next session. So, this capturing method. So, the space mission that is it can do the active space debris capturing and the removal. So, this consists of what are the phases. So, the first phase is that you need to launch and maneuver a that is called a chaser spacecraft which will facilitate the capturing of the debris. So, this phase is called LUOP. Then it will have to do a far range the rendezvous phase. So, rendezvous means the locating or finally you have to reach to that the target. So, there is one the chasing spacecraft and there is the target which you need to capture. So, then the next phase will come the close range rendezvous phase. Once that phase is over, then the next phase will be the capturing phase and the removal phase. So, these phases can be performed either autonomously. Autonomously means that is the spacecraft has the chasing spacecraft has all this, that is already it is loaded, that all the commands everything is loaded and it can perform autonomously. Other way you can do it by remotely controlled by the ground based mission operations. So, the capturing phase it plays a very crucial role in the entire mission process. Conceptually many methods for space debris capturing have been proposed, as I said, we will discuss a few of them. So, according to their characteristics, the methods are divided into two main categories. One is the the contact capturing method, the other is the contactless capturing method. So, the capturing and the deorbiting. So, it is this cartoon shows that is how it is done, whatever the steps I showed. So, this is shown here in this the cartoon. So, first the launch of that the chaser the spacecraft, and then you have to, that is the initial the orbit, and then the target orbit. Target orbit means the orbit in which this. So, this is the orbit in which the debris or this can be an abandoned spacecraft. So, that it has to be tracked that which orbit it is there, what is its trajectory. Once it is known, then this the far this rendezvous this thing can be done far and the near, and once that is done, then it is captured by the chasing. Then after that there can be two activities. It can be if it is in a orbit in a low earth orbit, suppose if it is in something like an 800 kilometers. So, it can be put in a higher orbit, it can be greater than 2000 kilometer, where this that the pollution is less and where there is no operational satellites are there. Other way it can be that is you deorbit it, you take it to the atmosphere. For that what is done, that is the perigee lowering. So, perigee lowering means that is its altitude is it is decreased, and that is done by the whatever the thrusters are there, that is that the perigee thrusters using those things. So, here it is written for this particular cases, it can be 1 to 5 and then it will deorbit and burn. So, this is the total phase of capturing and the deorbiting. It includes the capturing as well as the removal. So, this means it is the removal part. So, this is just one that it shows that is how this is how this one chaser spacecraft is able to capture one that is the debris one non-functional satellite. So, it is shown here. So, what is the method? We will now discuss the different space debris capturing methods and the deorbiting mechanism of course. So, the first one is the contact capturing method. So, one is the stiff connection. So, under stiff connection it can be tentacles capturing, we will see what is the tentacles used. Then it can be robotic arm, again robotic arm will have, it can be single arm or it can have the multiple arms. The other method is flexible connection. So, under flexible connection we will see one is the net capturing, then the thither gripper mechanism, the third one is the harpoon capturing. So, this is all about the different types of the contact capturing methods. So, the contactless capturing methods. So, here the one method is called the electrostatic detector, we will see what is that. The other is the gravity detector. So, all these methods we will see with the a little bit more details and with along with the cartoons, so that we understand what are these each method is. So, this material I have taken from this is the source of this is the reference for the material from which I have taken this. So, this is just an example of this that whatever I said, it is the stiff connection approach. This is the project of the ESA and the mission name is Clear Space 1 mission. It is scheduled in second half of 2026. This one similar mission that I have shown you in this second or third slide, one the GIF thing where how it was capturing. So, this shows already I discussed that is how it is the phasing is done and then the target, it reaches to the target orbit and the rendezvous and then it captures it. Now, the contact capturing method. So, the contact capturing methods involve physically the grabbing or adhering to the orbital debris using stiff or flexible connection based capturing, that already you have seen in that block diagram. So, what are the key techniques for the stiff connection? It can be tentacles or the robotic arms. So, what it does? It captures the debris using articulated manipulators mounted on the satellites. And the flexible the connection, they can use the nets or harpoons, already I told about this. Then it can have the deployable systems to ensure to ensnare or the tether space debris. Then it can be the adhesive surfaces, use of sticky material or gecko inspired pads to cling to the small particles. What are the advantages of this contact capturing methods? The advantage is this is the precise targeting and the retrieval. Then minimal fragmentation compared to non-contact methods, suitable for large or inactive objects. What are the challenges? Or the challenges is the high precision control required here, and the risks of collisions or the rebounds, complexity in dynamic space environment, because this the target is it is not a control one, its movement it is, and so that way so controlling it, that the dynamics, the orbital dynamics becomes very challenging. So, we will now see the stiff connection capturing. So, what is stiff connection capturing? It refers to a rigid mechanical linkage established between a chaser spacecraft and the debris target. So, this approach ensures a firm and stable attachment, facilitating precise control during the subsequent operations such as deorbiting or servicing. So, we will see what are the key characteristics of this stiff connection method. So, first is the rigid mechanical linkage. So, it utilizes the devices like robotic arms or tentacle like mechanisms or clamping systems to physically grasp and hold the debris securely. The second is the enhanced control. So, the firm attachment allows the chaser spacecraft to apply controlled forces and torques to the debris. So, which enables the precise maneuvers such as detumbling or the guided re-entry. Now, what are these this high precision requirements? Now, capturing debris with a stiff connection, it demands very accurate the rendezvous and the docking procedures. This is very important, especially challenging when dealing with non-cooperative or the tumbling targets. Non-cooperative, already I said, where you do not have any active control mechanism, you do not have any communication system. So, it is very difficult to deal with this type of non-cooperative or the tumbling targets. So, we will see further this tentacles capturing. So, capturing of orbital debris using tentacle like robotic arms. So, this is very emerging and promising approach in space debris mitigation. So, you can see this something like the octopus. So, this is the the natural way. So, you can see now this actual the gripper or the capturing the mechanism can be like that. So, this is the target how it had been captured by this tentacle arms. So, these mechanisms it offer the advantages over the traditional rigid arms, particularly in handling the unpredictable motion and the varied shapes of the debris in microgravity environments. This tentacle based systems offer several benefits over traditional rigid robotic arms. So, first of all it is the flexibility. So, they can conform to various shapes and sizes of debris, allowing for more secure captures, and because of this it is having the risk is reduced. So, there the compliant nature minimizes the risk of generating additional debris during the capture operations. Then this another very important feature is its extended reach. So, morphing or the telescopic design, it can enable these terms to extend their reach. So, by that it allows the host satellite to maintain a safer distance from potentially hazardous debris. So, now we will see a few example. So, how this can be performed? So, this can be performed either with or without robotic arm. With a robotic arm used, tentacle capturing embraces the space debris with a clamping mechanism after holding a point on the target by the robotic arm. And finally, a velocity increment by the chaser will deorbit the combined object. So, a trade-off shows the tentacle capturing with the robotic arm lead to a higher cost, mass as well as the volume, and the hazardness and complexity of design compared to the one without a robotic arm. So, this you can see this the schematic or the cartoon which shows like. So, you can see this is the capturing mechanism. So, it is having the rotary, this is the actuator, then this is the boom, and these are the lift springs, and finally, you can have the structure like that. This is in the closed configuration. So, this is another one, that is octopus what I showed. So, this is called the octo arm, this is the flexible way of the capturing, and this is called a teko gripper. So, this word it is a Japanese word. So, teko means octopus in Japanese. So, how this teko gripper works? So, this is a it is the all this that is the gripper, okay, and then this is having this will have a thrusters, and it is I will come to that, it will be clear that it is what it does. So, basically it is put on a mother ship or a mother the spacecraft, and then what it does, then the spacecraft takes it nearer to this the target, which is the debris, it can be a debris satellite, and then what is that, it separates from the, it is this tacho gripper is separated from the mother ship, and the tacho flyer then approaches the target. So, it approaches the target, and then finally, what is this, it grips or the target spacecraft. So, it makes an envelope grasp of the target, this is the way. Now, once this tacho gripper is having the thruster and the other system by which what is done, this satellite, that is this abandoned satellite, it is a non-cooperative one. Now, because of this tacho gripper, now it has, since it is having the thruster and the other the communication system. So, now the mother satellite will be able to send the proper commands, and in that way the deorbiting operation can be done. So, after the stabilization of the tacho flyer with the target captured by a robotic arm of the mother ship as a, now it has become a collaborative target because of this tacho gripper. So, this was showing the other type of the gripper. So, it is very flexible, and this is something because there is a lot of activities are going on. So, this shows the how it is being tested. So, this material has been taken from this paper. Okay. Now, that is the, so it involves this robotic stiff connection capturing mechanism. So, it involves using a rigid robotic system. So, it can be the arms, clamps, etc., to establish a secure, a non-flexible link between a chaser satellite and a piece of debris. So, previous one we have seen that is this capturing is a flexible one, but here it is it is not flexible, but it is a non-flexible link. So, this approach, it is particularly effective for active debris removal. It is also called the ADR missions that require precise control during the capture, stabilization and deorbiting phases. So, you can see these are the robotic arms. So, multiple arms are there, and this one is the, so this is in your changing spacecraft, and this is the target debris. So, once it is approaching it after the, it is these rendezvous, so it is able to capture target debris. So, for tentacles capturing and robotic arm capturing, the connection between the chaser satellite and the target is stiff. So, this makes the composite controllable and stable. However, the mass and cost are dramatically increased. So, to overcome this drawback, the following flexible connection capturing methods are proposed. So, what are those? So, this is one is the net capturing, the other one is tether gripper mechanism. We will see what is that. Then the third one is the harpoon mechanism. We will see this one by one. So, we will see what is the net capturing. So, net capturing, it is a net based capture systems, and it is a promising approach for removing the orbital debris, particularly in low Earth orbit LEO. So, these systems they involve, this is a deployable or a flexible net to ensnare the space debris, allowing for its subsequent deorbiting and destruction in Earth's atmosphere. So, you can see this is just a net. So, this is the tether, and you see how this net, and this is your the changing spacecraft, and this is the target debris. So, you see how the net is used to capture this abandoned spacecraft, or it need not be spacecraft, it can be the part of the upper stage of the launch vehicle. Now, the next is the thither gripper capturing. So, in this system a spacecraft is equipped with a robotic gripper that is connected to a thither. So, the gripper that captures the target debris, and the thither allows for a controlled manipulation such as deorbiting debris and moving to a designated disposal orbit. So, this approach is particularly effective for handling large as well as the non-cooperative objects in space. So, you can see what is that thither and the gripper. So, this is the target debris, and this is the thither, and this is the gripper. So, you can see this is the thither and the gripper, how it. So, these are all the grippers. So, this is the way the satellite can be or this debris can be captured. The next method is the harpoon capturing methods. So, here the harpoon systems, these are designed to intercept and secure the debris by firing a projectile into the target object. So, upon this impact of those the projectile, the harpoon it embeds itself into the debris, and then a thither is connected to the harpoon, which allows the capturing of the spacecraft to control the debris movement. And this approach is particularly effective again for the large, again it is non-cooperative targets like the defunct satellites or the upper rocket stages. So, this shows this is the harpoon or the projectile, which is so this is the shaft or the thither, and these are all these subsystem of this thing, and then you can show it here, it shows it. So, this is how the harpoon and this thither, and so this is again your it can be the debris. Changing spacecraft. Now, we will see that contactless capturing method. So, whatever the methods we are discussing, these are all the the contact methods by the different means. So, the contactless methods for the capturing and removing orbital debris are these are the promises due to their ability to mitigate the risks associated with the physical contact. So, what it can happen such as the collision or the damage of the active spacecraft. So, those the damage of the active or the chaser the spacecraft, or so all those the accidents can be, you can overcome those by using contactless capturing method. So, this technique employs forces or energy to influence the debris trajectories without direct interaction. So, a few of these techniques are this. One is called the electrostatic tractor or ET. So, what is electrostatic tractor? So, it offers a promising contactless method for capturing and removing orbital debris, particularly in geosynchronous orbit or geostationary orbit. So, this technique it leverages the electrostatic forces to maneuver debris without physical contact, reducing the risk of generating additional fragment. So, an ET equipped spacecraft emits an electron beam toward a piece of space debris, charging the debris negatively while the spacecraft becomes positively charged. So, when a electron beam is emitted from the changing spacecraft, so what it will do? It will get positively charged, and the target debris it will be positively charged. So, then there will be a force, that is this Coulomb force. So, by using that the trajectory of that the debris, it can be changed. So, this charge differential, it creates an attractive Coulomb force between these two objects. So, by maintaining a controllable distances typical 20 to 25 meters, the spacecraft can tow the debris to a disposable orbit such as a graveyard orbit in GEO. So, it can be put in some other the orbit above the geosynchronous or geostationary orbit, it is GSO. So, this method is especially advantageous for handling large and the tumbling objects that are challenging to capture using traditional mechanical means. So, this shows that is how these two spacecrafts are, one is positively charged the Chaser spacecraft, the other one is the negatively charged. So, there is the force of attraction. So, this way it can take it to a higher orbit and park it there. So, another method, that is the gravity detector. So, gravity detector method is leverages the mass of the spacecraft to impart a gravitational force. This is for this basically these are for the asteroid which can come to this which can hit the earth. So, this type of the gravity detectors are used to change the trajectory of the asteroid. So, this involves the concept of gravity detector involves the spacecraft that uses its gravitational pull to alter the trajectory of another object in space. It can be asteroid without making a physical contact. So, this method also can be used for the debris control. So, it can it could deflect suppose a hypothetical asteroid by 140 meters across, but it big enough to cause the regional, that is the devastation if it hit the earth. So, this is the concept, this concept is shown here, how the gravitational pull changes the track of an the unwanted object. So, with this I will end it here, and we will continue with this same topic in our next session. Thank you very much.